we've got oxidation, and so AMPK sees that and says, oh, by the way, we've also got to turn off that signal now, so it tells you to make your own endogenous, that means in the body, antioxidants. And so the oxidation is created, and then you make an antioxidant response, and everybody's happy. Another source of oxidation, though, can come from plant-derived compounds. For example, nicotine or sulforaphane, resveratrol, cucuminoids, quercetin. All of these work not by giving you antioxidants, but by creating a toxic oxidation effect. And your body, in response to that stimulus, says, oh, okay, we're going to turn up AMPK and get in the energy mode, and also we're going to ramp up our own supply of antioxidants. So there are some cases, actually, where you can use a little stimulus of a poison and give that to your body, and it will make more antioxidants than needed to overcome that stimulus, and that might actually be able to mop up some rampant oxidation. It's talking about how nicotine actually works by ramping up AMPK, which then generates or allows you to burn fat, lipolysis. So it's well known, right, that smoking and nicotine can cause you to lose weight, and it's a problem when you try to quit. And they're talking about how this, well, it lowers your body fat, but it also creates insulin resistance, and I think they might be a little bit confused about whether that insulin resistance is good or bad, but in this case, it's just giving you fatty acids, and so it's probably good. But this is actually the same principle that all of these other factors use. So you may have heard that sulforaphane is a superfood compound, and resveratrol. All of them work through AMPK. And I just want to note, though, but this isn't an argument for getting those compounds from food, because the amounts that are involved are just way beyond what you could get from eating a plant-based diet. This is just one paper that was giving an example of resveratrol. How much red wine would you have to eat to get enough resveratrol to get a therapeutic dose? Somewhere between 500 and 3,000 liters. Insofar as plants are inducing this energy mode, they're doing it through pharmacological doses, not through just eating plants. And it's not because of antioxidation, it's actually because of oxidation. And when we isolate antioxidants and see if that helps, actually we find that it does things we really, really don't want. So doing exercise, for example, creates oxidation that is used as a signal that tells us to build our muscles. And if you give too much antioxidation from the outside, it shuts off that signal and you don't get the benefit. That's because it comes from this mitochondrial signal. There are times when we need to build up. And this is a paper that's called intermittent metabolic switching. And the theory that they're trying to explain in this paper is that there are two modes, like we've already talked about, and you actually really need both of them to be healthy. So you might hear a lot about how the energy mode, when you're in ketosis or when you're fasting, you get all this stimulus for autophagy, and you get, for example, an increase in BDNF, which is brain-derived neurotrophic factor. That is something that's telling your body, hey, we need to make more neurons. And there's all kinds of parallel stimuli for things that we need to make. But what might be missed when we talk about this is that that building doesn't actually happen until you go back into the building mode and give yourself the material to follow through and make those neurons, and make that protein and make those synapses. So these things have to work together. You can't have just one without the other and expect to get benefit.